All right, cool. Hello, Berlin. Woo! It's my second in-person conference since COVID. Nice to be here. Nice to see all of you. Woo! So today we're going to talk about Flipper, and well, our host, they kind of stole my entrance. What Flipper is? Flipper is a debugging platform for your mobile, desktop, and any kind of other hardware. Hopefully one day you'll be debugging your microwave with Flipper. And over the last year, we've been working relentlessly to reimagine what Flipper is. For a long time, Flipper's been an electron application that's been merely a companion for a developer to take a peek inside of any kind of application state or logs or whatever. And we're trying to push Flipper to become a part of our and hopefully your critical infrastructure, to become a part of your automated verification procedure, and to start, well, to make Flipper live in your CI cloud. And before we talk more about it, let me say a few words about myself. So yeah, this is me looking very serious somewhere in the mountains snowboarding. I'm a software engineer working full-time on Flipper at Meta. And our plan for the day is to talk about what Flipper is. This is our mascot, by the way. And I'm going to do bad things with this mascot. First, I'm going to decapitate this mascot. So the next stage of our talk is going to be how we made Flipper headless and how we introduced API to Flipper, how we made some profit off it, and how hopefully you can use headless Flipper in your CI. And last, I'm going to tell you how we're trying to embed headless Flipper into our CI infrastructure at Meta. And Flipper is, before I get to the next slide, could I see your hands on a question? How many of you guys know what Flipper is? Wow, yeah, that's so much better than the previous conference. Yeah. Okay, and how many of you use Flipper on a daily basis? Wow, that's quite an audience here. Thank you. Well, for those of you who didn't raise your hands, hopefully by the end of this talk, you'll know what Flipper is and how you can use it. So Flipper is a platform for debugging iOS, Android, and React Native applications. Visualize. Yeah, clearly this is a joke. I'm hoping for a laugh here. Not a very good joke, huh? OK. So you can imagine Flipper as Chrome DevTools for your mobile hardware, or actually, as I said before, any kind of hardware for which we have officially supported clients, or optionally, and hopefully you can write your own client to communicate to Flipper. And just to get you some context, this is Flipper. This is Flipper inspecting the layout of some React Native application. And this is Flipper. This is Flipper inspecting network state of the same React Native application. And this is Flipper fetching the logs from that device so you can see what's going on there. And last but not least, and kind of weird, this is Flipper as well, playing tic-tac-toe with your device. We're going to get back to that slide later, and I'm going to explain in detail why it's there. So to wrap up, in simple words, Flipper is a device discovery service with a message bus. And it wouldn't exist without its plugins. So all the screenshots that you saw before, they were different plugins using the device discovery and the message bus to do all this awesome stuff. Yes, including tic-tac-toe. And now, let's take a short breath, primarily for me to relax. And overview the Flipper architecture. So in the middle, we have Flipper. We have various devices that are trying to connect to Flipper to be discovered by Flipper. So yes, discovered, we have the device discovery service, which uses ADB for Android, IDB for iOS, some Metro for React Native to discover devices, various devices. And once these devices are discovered, we display them in a hopefully nice, readable UI for developers. Like this. Let's put letters on one side to the letters on the other side. And once the devices are discovered, Flipper initializes the plugins for every device, whether it's Android, iOS, React Native. If the plugin is available and if the plugin is enabled, it's going to get started, and you then can switch between plugins and peek into different states and different views of your application. We open sourced quite a lot of plugins. Just a few examples. For instance, that logs plugin, it's available in open source for free. Another plugin is CPU utilization, and we have many, many more available on our GitHub. Yeah, and I think I forgot to mention that Flipper is open source itself. Huh? OK, so yes, Flipper is open source as well. And the good part here is that, well, we have some plugins here and there. So what's the main benefit of Flipper, really? Well, in my view, the main benefit is that you can write your desktop part of the plugin that draws this nice UI, which is usually kind of complex, only once. And then you can reuse this plugin for any other device. Yes, you have to implement the device-side counterpart of the plugin for every platform, but it's usually extremely simple, or I'd even say trivial. For instance, for our navigation plugin that makes the device go from one screen to another, this is, in a nutshell, this is the entire application. This is the entire plugin. Well, when we strip the boilerplate code from Java, this is it. We just teach the device plugin how to act when it receives a command from the desktop part of the plugin. So as you can see, it's not that much code, and you can easily re-implement this code for any platform that you have, and then the most complex part, which is the desktop plugin, stays the same for any platform. So for instance, when you develop an application that is cross-platform and you re-implement it for different platforms, say Android, iOS, maybe some desktop part of the application, and this application shares maybe some common state, you can write a plugin that is going to fetch this state universally for any kind of platform. But that's not the end of the story. We've overviewed the device plugins, and Flipper would be only halfway there if we stopped there. Also, at least in Meta, the great benefit of Flipper comes when we start creating specialized plugins for every application. Because you can do only so much when you consider the device as, well, in general. But when you start examining a specific application, there where Flipper shines. So here we have various devices starting different applications. These devices, these applications, they proactively connect to our WebSocket server, which we host in Flipper. And then once the applications, they are connected to Flipper, we show these applications in the UI. But that's not the end. We also create a message bus. And now, the desktop plugins, they can use this WebSocket message bus to communicate to the applications on the devices. And once the devices are discovered, the applications are discovered, Flipper starts plugins, the desktop side of the plugins, And then the desktop side of the plugins commands the applications to start the client-side counterparts, like this. So it's like a single plugin which has two pieces, the desktop part and the application part. And they exchange messages over that WebSocket connection. And this is the moment where the imagination can run wild and free, where the sky is the limit. Another question for you guys. How many of you have ever written a custom Flipper plugin? OK, that's very normal. That's very normal. To be honest, I did it not voluntarily. I had to do it. They forced me. But actually, it's extremely simple to write a custom plugin for your Flipper application. And I'm going to get into details of the desktop part of the plugin later when we consider this tic-tac-toe. But you already saw that for the client side of the plugin, it was like trivial, right? So, well, once we let our imagination run wild for a few minutes, sorry, we don't have a few minutes, so I'm going to jump straight to ideas of how you can use Flipper. For instance, we all developed complex, large applications, right? And usually, these applications, they have enormously complex state. How many of you have ever debugged that complex state by abusing console log or printf? Yeah. Whew. At least now I'm not the only dinosaur in the audience. So imagine that instead of abusing console log or printf, you could write a plugin that would reflect the state of your application in real time in some sort of a table. And then when you run your application, you no longer have to recompile it or wait for hot reloading to kick off. You just see your state, your complex state live in a table. Wouldn't it be cool? Or we saw the navigation plugin, well, at least a bit of it. And what if Flipper could command your device to go to certain screens? What if you used Flipper in some automation scenarios? For instance, well, you want your device to take a series of screenshots of different screens to submit them for validation to your designer. What if you could command Flipper to navigate to these different screens and take screenshots there? That's possible with Flipper. Or what if you have some custom hardware? Well, for instance, this guy. Well, this is not developed by Meta, but this is just regular wristband. I think Xiaomi. And, well, what if you don't want to bother with connecting your hardware to your PC, to your laptop, and you want to just spin some sort of simulator easily? That's where Flipper can help you. Flipper can simulate the data or the events that this piece of hardware sends to your device, and therefore you can easily start a simulated device and debug your application. For instance, well, your Android application that integrates with this watch. So concluding it, Flipper can command your device to do anything. Well, when you have a message bus and you can some sort of framework on both sides, it's trivial to use this message bus as some sort of RPC and send commands and get the replies back. On to the next part, splitting Flipper in half. So for a long time, Flipper has been an Electron monolith. It's been frowned upon Electron application. I know that many of you guys probably hate Electron. Yeah, don't judge us. Don't judge us. I see judgmental looks there. So this is roughly the high-level architecture of Flipper. We have the server part of Flipper, well, yeah, there. The server part, where we have the device discovery service, the message bus, where we start the WebSocket server for device discovery, and we have the UI. And when it was Electron, they all lived together inside of a single Electron application. And in terms of Electron, we had some sort of browser, web view, whatever you may want to call it, process where we had the UI. We had the Node.js process where we hosted the device discovery and the message bus, and via some sort of Electron magic, they communicated. And that setup, it implies certain restrictions. Let's consider this scenario where we have a laptop with Flipper and we want to connect to some simulator which is not local to our laptop, but which lives in a cloud somewhere. How could we do it? Well, one of the things we could do, we could forward the ports from the cloud to our laptop. That's not so hard, right? Anyone could do port forwarding these days. So yeah, that problem is solved. However, what if you have a laptop and you want to have stable remote developer environment? So you can jump between different laptops, different PCs, but you have some sort of cloud with your developer environment somewhere far away, in a galaxy far, far away. And you want to develop your application using that remote machine, that remote environment. And that remote environment in its place connects to the cloud, a different kind of cloud with your emulator. Then, well, how do you really see the Electron application's UI from your laptop? Well, you can do RDP, Remote Desktop Protocol. And I'm going to do a head count one more time. Hopefully it's the last, I promise you. Do you guys like RDP? Well, no, I don't want to raise my hand. Okay, at least you're my hero, mate. You're my hero. Just, yeah, for some reason, I can't digest RDP. It's usually laggy, or maybe it's me laggy, or maybe it's just some, I don't know, stereotypical thinking. But nevertheless, when I do remote development, I usually want to have my VS Code here on my laptop and use some kind of VS Code remote headless agent there. And then the VS Code, it can use some custom binary protocol to do the efficient communication. So, well, at least in my view, for me, it works better. And in that setup, if you don't have an RDP, you can't access headless, well, non-headless Electron Flipper there. Or another scenario where you have a script, some sort of automated script that wants to connect to the same remote developer environment and use Flipper. How would it connect to the device? How would it use Flipper? Would it click on the UI? And then how would Flipper relay the commands back to the cloud? So many questions, so little answers. So the solution there is to maybe decapitate Flipper, to have the Flipper UI or Flipper client embedded into the script. And then the Flipper server part could live in the cloud and easily, without even port forwarding, communicate with simulators. Or we could have the Flipper client with the UI running on our desktop as a web application. And then it would use, for instance, WebSockets to communicate to Flipper server on our remote desktop, remote developer environment, and we could do port forwarding to forward the ports from the cloud. Wouldn't it be awesome? So in short, that's what we did. We extracted the Flipper UI as a web application. And as a bonus, it allowed us to start embedding Flipper anywhere as an iframe. So for instance, you have other developer tools in your company that have some sort of web UI, or maybe, well, even VS Code itself. You can now use Flipper as an iframe in your VS Code, and you can collocate your different developer tooling. Personally, I'm not a huge fan of collocating, but for some people, and I know that for sure, we asked around, that's what they want. So the current setup looks like this. we have a web app with the UI. We have the WebSocket connection, and it connects to Flipper server. But that setup doesn't really uncover how script could use Flipper, right? Because it's still UI, and I'd say that it would be quite hard to teach a script to click on the UI buttons. So that's where the UI comes into play. Let's recollect the previous setup. Ooh, I'm running out of time. Previous setup, we had some UI, device discovery, message bus, devices, and pay attention to this red circle there. The plugins, they live in the UI, and that's not a mistake. So for historical reasons, because for a long time Flip has been an Electron application, we placed the state of the plugins in the UI. And that's a huge problem when you want to start using Flip in headless mode, when you want to start using API, because you no longer have this UI which hosted this state. So one of the ideas that you could do here, you could somehow place the state of your plugins in your CLI, for instance. The only reasonable way to do it, in my view, is to make CLI yet another Node.js process. And the problem here is with Node.js itself. Well, don't get me wrong, Node.js is great tech. I love Node.js. But it limits how we can distribute the CLI. What if we want to distribute it as a binary? Or maybe, what if we want other clients, desktop clients, to easily integrate with Flipper? Then they would have to start a companion Node.js process and somehow talk to this Node.js process from their application. It's just, it doesn't really work that well. So another idea is that, and that's the idea that we actually went with, is that, well, we already have the Node.js process. Why don't we move the plugin state from the UI to that Node.js process? So we did some code extraction. We created yet another package that we shared between the UI and Flipper server. And now Flipper can do both. When you start an Electron application or when you start a UI, the plugin state, it lives in the UI. But if you want to connect from your headless client, for instance, CLI, which doesn't draw any UI on the screen, it can tell Flipper that, hey, dude, please host the plugin state on your side. And that's where we go back to that tic-tac-toe. By the way, it's yet another open source plugin which you can take a look at. I'd like to briefly go over the code, and I'm definitely running out of time. So this is the desktop part of the plugin. We create some state, which is going to be later shared with the mobile device, so the mobile device can draw the plugin correctly. You can consider this plugin function as the brain of your plugin. We define there the state. We define there the APIs, what the plugin can do. For instance, it can send update to the mobile. It can make a move. It can reset its state. It can do some magic when it connects, when the device connects to the plugin, to Flipper, and it can export some of these API functions, some of the state, so this API can be used later in headless mode or by the UI. Let's briefly go over some API functions so you get the idea of how they work. For instance, this is the make move function, which accepts which player is making a move, the move itself. Then we validate if it's the correct player who's making a move, and if the move is legal. And then what we do, we calculate the next state in our desktop, and then we send the update to the mobile. So once again, the mobile there is extremely simple. It just sends a message with the move when user clicks on a button on a phone screen, and it draws the state that is computed on the desktop part of the plugin. This is send update. Really, really simple. We just send a message with the serialized state. And this is the magic that happens when we connect. So when we receive a message X move from the device, it means that device made a move, and well, we have to calculate the next state and send the update. When device wants to get a new state for some reason, well, we get the message, get state from the device, and we send the update. And once we connect, we just proactively send the initial state of the game to the device. And this is the UI. It's a React UI. Probably lots of you know how to build a simple or not so simple React application, so I'm not going to dig into that too much, especially since I'm out of time already. So, but basically, you see that there on the second line, use plugin function, which exports that API that imports that API that we exported before, and it uses that API, these make move functions, the state from that API, and etc. And with Headless Flipper, we now can export one more function that kind of whitelists or maybe even wraps the API exposed by the brain of your plugin. So this function tells Flipper which API calls are available from the headless side. And in a nutshell, it functions like a simple RPC. We have the API, which is Flipper. We have the CLI, which is headless client. And whenever a headless client wants to do something, wants to make Flipper do something, it sends a message, a JSON message to Flipper. Then Flipper runs the API call accordingly to the data that it received, and then it sends the reply back. So yeah, RPC and demo time. Yeah, sorry, I'm too much of a chicken to do it live, so it's a video, it's a pre-recorded video. And this is me playing the game of tic-tac-toe from my mobile with the UI. It's what we had for a long, long time. And this is me connecting from a terminal. Yeah. Now we don't have any UI, but we have a terminal, and we can play the same game of tic-tac-toe from a terminal with the device. Yeah, the game is going, yeah, and did I lose? Did I win? Yeah, I won. Lucky me. OK, yeah. I promise I'm about to finish. Sorry. I'm sorry. My apologies for the next speaker, and my apologies for the wonderful host. So, well, yeah, let me rush through how we use Flipper at Meta. I kind of voiced the idea of verifying the design before, so that's what we have at Meta. We have amazing mockups, and we have, well, when other people work on the implementation, it's usually great. When I do that, it's usually poor. So yeah, I'm the person who needs this design verification procedure, and it works like this. Well, here's the setup. And we want the developers, when they implemented a screen, we want the developers to submit a command in their CLI, in their terminal, favorite tool of any developer, right? This command, this CLI, connects to Flipper and starts our UI validation plugin. This plugin goes to the device, grabs a screenshot there, gets the screenshot back to the plugin, and submits the screenshot to the cloud. And then our designers can go to the cloud, can go to the actual diff with the implementation, where we did the implementation, and compare the mockup with the actual screenshot, and either give a green light or say that we have to do it all over again. And the idea that I love the most is testing. So we have some end-to-end testing setup at Meta, which uses Jest. And usually developers, they have some sort of terminal CLI where they start their end-to-end test suite, they have their browser where they can see the results of that test suite. That test suite is run somewhere there in the cloud. And it has some different cloud where we have the devices infrastructure, our simulators. And the idea is that, well, quite often, your end-to-end tests, they break, and you start ripping your hair apart trying to figure out why. You replay the videos from your end-to-end test suite. You once again add console logs, and it takes just enormous amount of time. And we thought that we would add Flipper server next to the emulators, and we would expose Flipper UI to the users in the browser. So whenever an end-to-end test runs, we can see what exactly is happening with the device. And as you remember, we have lots of plugins made specifically for every application, so we can see in detail the state of the application. Yes, I'm so sorry. I'm so sorry. And that's why, once again, the imagination can run wild. Say, for instance, yeah, I promise this is like very last slide, where the imagination can run wild. When you have the data from the application, when you have this detailed state, what if you could use Flipper ingest end-to-end test suites themselves? What if you could assert the state of your applications? What if you could do some snapshot testing, for instance? We didn't get there yet. It's one of the ideas for the future. But if you feel inspired and if you want to do it for your company, please give us a shout on GitHub or on Twitter and tell us about your experience. And yes, embed Flipper in your CI, like now. Yeah, and this is the links to the demo that we saw before that you can run on your own. Links to our Twitter, to our GitHub, my Twitter and my GitHub if you want to abuse my DM and ask everything you want, anything you want about Flipper. Legal stuff, the pictures that I used in these slides. And finally, the QR code leading to my GitHub, where you can find the slides. Whew. I totally abused the stage, the time, and the hospitality of this conference, but thank you guys.